Good day, everyone. This is Claire Margarette C. Dasig of CM113P, Section A14. Today, I will solve four problems regarding mass relationships in chemical reactions, reactions in aqueous solutions, thermochemistry, entropy, free energy, and equilibrium. First, we have here problem 3.13. How many atoms are there in 5.10 moles of sulfur? So the given here is 5.10 moles of sulfur. We know that 1 mole is equivalent to 6.022 times 10 raised to 23 atoms. So to get the number of atoms in 5.10 moles of sulfur, we will multiply it to Avogadro's number. So 5.10 moles of sulfur times 6.022 times 10 raised to 23 atoms over 1 mole. Cross this out. Then we calculate. The answer is 3.07 times 10 raised to 24 atoms of sulfur. So there are 3.07 times 10 raised to 24 atoms in 5.10 moles of sulfur. Next, we have here problem 4.64. Describe how you would prepare 250 ml of a 0.707 m of NaNO3 solution. To prepare this, we need to find the moles of sodium nitrate. From the given, we have 250 milliliters of solution. Since this is in milliliters, we are going to convert it to liters. Then, we will multiply the molarity of given, which is 0.707 moles of NaNO3 over 1 liter. So cross out this one, this one. So calculate, and the answer is 0.177 moles of sodium nitrate. Now that we have the moles of sodium nitrate, we can get the mass of it. But let's first find the molar mass of NaNO3. NaNO. We have 1 mole, and 3 times. Na has a mass of 22.99 and has a mass of 14 and 16. So we have here 22.99, 14, and 48. The total is 84.99 grams per mole. So this is the molar mass of sodium nitrate. Next, let's proceed now to find the mass. So 0.177 moles of NaNO3 times the molar mass, which is 84.99 grams of NaNO3 over 1 mole of NaNO3. Cross this out. So the answer is 15.0 grams of sodium nitrate. So now we can say that we can prepare the solution by adding 15 grams of sodium nitrate to a 250 milliliters of volumetric flask, then add enough water to dissolve all the solid and fill the flask to the mark to make a 250 milliliters of solution. Next, we have here problem 6.32 about thermochemistry. A piece of silver of mass 362 grams has a heat capacity of 85.7 joules per degree Celsius. What is the specific heat of silver? So we can find the specific heat of silver by dividing the given heat capacity by its mass. So specific heat over 85.7 joules per degree Celsius over 362 grams. So we calculate this and the answer is 0.237 joules per gram per degree Celsius. So this is the specific heat of silver. Next, we have here problem 17.18 about entropy, free energy, and equilibrium. So the change in free energy that occurs in our reactions form its elements in their most thermodynamically stable states at standard state conditions. To calculate the standard state free energy of a reaction, we can consider this formula. So the sum of the free energies of formation of the products minus the sum of free energies of formation of the reactants. To do this, we need to find the free energy of each element and substance and multiply it to the number of moles. Refer to the Appendix 2 of our book for the thermodynamic data. So first, we have here this equation. Let's use the formula to get the standard state free energy of a reaction. So in the product side, we have here 2 moles of magnesium oxide. So 2 times negative 569.6 minus, in the reactant side, we have 2 moles of magnesium and 1 oxygen gas. So both magnesium and oxygen gas have 0 free energy. We have here 2 times 0 plus 0. So we calculate this and we get negative kilojoules per mole. So this is the standard state free energy of the reaction. Next, we will just copy the process we did earlier. So in the product side, we have 2 moles of sulfur trioxide. So 2 times negative 370.4 minus the reactant side, we have 2 moles of sulfur dioxide and 1 oxygen gas. So sulfur dioxide has a free energy of negative 300.4 and oxygen has 0. So we calculate this and we get negative 140 kilojoules per mole. So this is the standard state free energy of the reaction. Lastly, we have this equation and we will repeat the process again. So in the product side, we have 4 moles of carbon dioxide and 6 moles of water. So 4 moles times the free energy of carbon dioxide is negative 394.4 plus 6 moles of water, and its free energy is negative 237.2 minus. So in the reactant side, we have 2 moles of ethane and 7 oxygen gas. 2 moles of ethane and its free energy is negative 32.89 plus oxygen, which is 0. So we calculate this part first. The product side, we have negative 3000.8 plus the reactant side, we have 65.78. So finalize the answer. We have negative 2935.02 kilojoules per mole. So this is the standard state free energy of the reaction. So I hope you learned something here. Thank you for listening.